Hi students, now we will be solving this particular problem. Now this particular problem that I'll be solving now is actually a problem based on proper substitution only. But there is a little bit of trick that needs to be applied here, okay? So that we can simplify the problem and solve it easily. Before getting into the part of substitution, what is the essential requirement for solving this problem? It is that in the numerator you have to do some very quick manipulation, okay? And why did I do this particular manipulation? This x minus x is 0 only, so ultimately you will actually be left with a cos x plus x sin x in the numerator. Then why did I put an x minus x here? Because what my target here is to actually, I want to somehow bring the format of x plus cos x in the numerator, okay? And also make the process of substitution more reachable, okay? As I solve the problem, you will be able to understand why. Now I will club the two together. Which one I'll club? I'll club x and cos x together, and I'll club minus x and plus x sin x together. So if I club x plus cos x, it will be as it is. And here if I club minus x and x sin x, by taking x common, then I will be getting somewhat this. I hope you are able to understand what I am trying to do here or reach here. So you basically had a minus x plus x sin x, right? So if I take x common, then I'll be left with a minus 1 plus sin x, alright? But if I take a minus common also here, then this minus will become a plus and this will become a minus. That is what I did here. When you actually break this, you get this, right? Alright. So now that I have come to this particular point, I hope you got this. Now that I have come to this particular point, what will I be doing is simply separate, okay? What is the separation that I'll be doing here? Alright, so I'll be left with a x cos x in the numerator, x plus cos x in the denominator, dx minus integration of x 1 minus sin x divided by x plus cos x into dx. If I do that, then this part will get cancelled and I will be left with a 1 dot dx here, and here I'll be left with x gets cancelled, so ultimately I'll be left with a 1 minus sin x dx divided by x plus cos x. Now we have reached a particular format here, okay? Here we don't need to do any substitution. This is direct integration, right? But here we need to do a substitution, and what that substitution should be? It will be x plus cos x equal to t. If I put x plus cos x equal to t, then I'll get 1 minus sin x dx as dt. So I'll replace this x plus cos x as t and 1 minus sin x dx as dt, okay? So ultimately what we will be having is integration of this is entirely dt and I'll be left with a t. Alright. So finally we will get a term based on log only. I am sorry, I did a mistake here. There is a 1 by x here. A 1 by x here. So integration of 1 by x dx is nothing but, this is a minus, is nothing but log of mod x, right? And this is log of mod t plus c. This can be further written as log a minus log b formula. I hope you know it is nothing but log of what? A by B. These are very basic formulas, okay? But don't worry, all of these things will be discussed in the upcoming videos. I'll discuss all of the logarithmic formulas, and also I'll be discussing the very basic formulas and some of the very basic concepts in logarithms as well, because if log is not clear to you, you will keep on stumbling. All right, because log is a very important function that needs to be well known and applied. Now in the next part, I'll just replace this t by what? X plus cos x, right? So this is the final answer that I'll be getting. Okay. Next, I'll try to solve an easy problem now. Okay, this one is an easy problem, because the substitution that this is actually, I think, a board exam problem. Okay, so this problem is easy because the substitution part is very easy here. We don't need a very complicated substitution method here, because here we will be considering e to the power x itself as t, and if I do that, what will I be getting? After taking the derivative, we will be getting e to the power x dx equal to dt. Okay. Now, how will I transform this particular format? Can I not write e to the power 2x as e to the power x into e to the power x, and the denominator is as it is? Can I not write it in that way? Yeah, I definitely can. Do you remember the concept of power? That these powers get added up to give us 2x. Okay, so I hope you know it. All right, next is I'll be now considering this so e to the power x we will be considering as a t, and e to the power x dx we will be considering as a dt, and in the denominator we have 2 plus e to the power x, which we will consider as 2 plus t. Now we have to again do a manipulation here. As you see that there is a complicated denominator, so try to bring the denominator in, try to copy this format in the numerator itself. If I do that, then as you can see, we have forcefully taken a 2 here, right? So I need to subtract it by a 2 so that the numerator remains a t only. So as I do this, what will happen is I get a very known format of denominator and numerator, because when I separate these two, all right, 2 plus t by 2 plus t is nothing but integration of 1 into dt, and this will become 2 by 2 plus t into dt. So here I'll be left with a t only. The integration of 1 dot dt is t only, and here 2 will come out as a constant, and as we know, integration of 1 by 2 plus t dt is nothing but what? Log of 2 plus t, okay, plus c. And then finally t will be replaced by e to the power x, okay, sorry, this will be 2 plus e to the power x plus c. E to the power x minus 2 log of 2 plus e to the power x plus c. So this is the final answer for this particular question. Okay. Now if you like my video, please don't forget to like, share, subscribe, and hit the notification bell icon for more of such exciting content. Keep sharing my videos, because you know, the more these videos reach out to the other students who actually need it, they will also benefit from the respective problems that I'll be solving. All right, so let's move on to the next problem.